You may wonder that why every object falls down, but it is more accurately to say that every object falls towards center of Earth or center of any celestial body due to its gravity. And how do we visualize the gravity? We visualize the gravity with the help of these gravitational field lines that you see on my screen. All of these field lines are directed towards center. The reason, because if we will release any object close to the surface of Earth, where the gravitational field strength or gravity is almost same uniform, then it will fall down towards the center with a constant acceleration due to gravity that is negative g. In the case of Earth, it is negative 9.8 meter per second square. So these are the gravitational field line, and this value can vary with respect to the other planets. Now, in our question is about the free fall motion. Why? Because we assume that the air resistance is negligible. So when air resistance is negligible, then there is a no force exerted on an object except the force of gravity. That's why the acceleration is equal to the net force over mass, and that is equal to negative mg. We will consider the direction of the force also, so that's why it is negative g. So in all the free fall motions, acceleration is always taken as negative g. Okay. Now in our question, you see that at the time t is equal to 0, if you release a ball, it will, what pattern, if we take the screenshot, if we take the pictures of this falling ball after every 1 second, so then you will capture something like this pattern. You will observe that in every next second it will cover more and more distance, because we claim that it is moving with a constant acceleration. And for a constant acceleration, dear students, you know that the distance time graph, I'm talking about distance time graph, increases proportionally, exponentially, like this. So what will be the distance covered in the 4th second? When we know acceleration is constant, so why not apply Seward equations? Because these equations deal all the problems related to free fall motion. So S is equals to ut plus half at square, right? Now we know that we have released it from the rest, so initial speed is 0. So the S is equals to just 1 over 2, and A is negative g, and the time t square, so which is negative 1 over 2 gt square. So if you want to know what is the distance covered in a 4th second, so there are two ways to prove it. So the method one is, dear students, we will calculate the distance covered in 3 seconds and the distance covered in the 4 seconds, and then we will subtract it. So I mean to say, why not if we find that what is the distance covered in the 3rd second and the distance covered in the 4th second. Let's call it S4, right? And I'm saying distance, so I will just take a positive values. So don't you think this is the distance covered in the 4th second, which is S4 minus S3? So what is the distance covered in the 3 seconds? It is equals to 1 over 2. Now I'm not writing negative sign because I'm finding distance into, better is that if we take 10 and 3 seconds, 3 square. So it will be how much? It will be 90 over 2, which is 45 meters. It means that this ball has covered 45 meter in first 3 seconds. In the same manner, S4 will be equals to 1 over 2 into 10 into 4 square. So that will be equals to 160 over 2, which is 80 meter. So the answer is 80 minus 45. That should be equals to 35 meter. It means it covered 35 meter in the 4th second, not in 4 seconds, in the 4th second. Now you can also find out the same answer by taking ratio, because once you know that the distance is directly proportional to the t square, because the g value is constant, you can take a ratio, right? You can say S4 over S3 over S1. is equals to the 4 seconds divided by 1. So that will be equals to 16 times S1. In the same manner, the S3 over S1 will be equals to the 3 square over 1 square. That will be equals to 9 S1. So from here you can subtract them, because I told you this is the distance covered in the 4th second, right? So that will be 7s1, and the distance covered in a 1 second is always 5 meter. Okay, so that is 35 meter. And how do I get 5 meter? 1 over 2 into 10 into 1 square. Okay, so I hope the both methods you get all of that. See you in the next video.